Degrees of freedom. The total number of coordinates or independent quantities required to describe the position and configuration of the dynamical system completely is called the number of degrees of freedom of that system. In general, the number of degrees of freedom in a system is given by n is equal to 3p minus r, where p is the number of particles in the system, r is the number of independent relations among the particles or common coordinates of the particle, and n is the number of degrees of freedom of a system. Let us now calculate the number of degrees of freedom for monoatomic, diatomic, and triatomic gases. Monoatomic gases. Monoatomic gas molecule like molecule of neon, argon, helium, etc. is made up of a single atom, so that P is equal to 1 and hence R is equal to 0. N is equal to 3 into 1 is equal to 3. Thus, the number of degrees of freedom of monoatomic gas molecule is 3. Diatomic gases. Diatomic gas molecule like molecule of hydrogen, oxygen, nitrogen, etc. is made up of 2 atoms, so that P is equal to 2 and hence R is equal to 1. N is equal to 3 into 2 minus 1 is equal to 5. Thus, the number of degrees of freedom of diatomic gas molecule is 5. Triatomic gases. Triatomic gas molecule like molecule of SO2, H2S, etc. is made up of 3 atoms. The triatomic gas molecules may be linear or non-linear. Central atom as shown, so that P is equal to 3 and hence R is equal to 2. N is equal to 3 into 3 minus 2 is equal to 7. Thus, the number of degrees of freedom of linear triatomic gas molecule is 7. In case of non-linear molecule, 3 atoms are present at the vertices of a triangle, so that P is equal to 3 and hence R is equal to 3. Therefore, N is equal to 3 into 3 minus 3 is equal to 6. Thus, the number of degrees of freedom of non-linear triatomic gas molecule is 6.